Good morning to everyone. My name is Panindra and today I'm here to present my tech talk presentation on topic study of Laplace transforms and its applications. So let us start with an abstract. The concept of Laplace transform plays a virtual role in wide fields of science and technology such as electrical and communication engineering, quantum physics, solution of partial differential operation, etc. This paper provides the reader with a solid foundation in the fundamentals of Laplace transforms and gain an understanding of some of very important and basic applications of this transformation. So, introduction. Transformation in mathematics deals with the conversion of one function to another function that may not be the same in domain. Laplace transform is very powerful transformation tool which literally transforms the original differential equation into an elementary algebraic expression. This later can then simplify and transform once again into the solution of the original problem. So this transform is named after the mathematician and renowned astronomer Pierre Simon Laplace, who lived in France. He uh, first discovered he invented this Laplace transform technique. The definition of Laplace transform. Suppose that f is a real or complex valued function of the variable t is greater than 0 and s is a real or complex parameter. We define the Laplace of f as f of s is equals to L of f of t, which is given by integral 0 to infinity e power minus st f of t dt. If you see into the figure, you can easily understand this formula. T is domain and S is equals to domain, and it is given by L of f of t is equals to f of s, where f of s is integral z to 0 to infinite e power minus t and f of t dt. Existence of Laplace transform. F of t must be piecewise continuous, which means that it must be single valued, but it can have a finite number of finite isolated discontinuous for t greater than 0. F of t must be exponential order, which means that f of t must remain less than m into e power at as t approaches the infinite, where m is a positive constant and a is a real positive number. Elementary properties of Laplace transformation. Linear property. If C1 and C2 are the constants, while F1 of t and F2 of t are functions, with Laplace transforms F1 of s and F2 of s, then they can be written as C1 F1 of t plus C2 F2 of t can be written as C1 F1 of s plus C2 F2 of s. First shifting property or first translation, it is given by L of f of t is equals to f of s, then L of e power at into f of t is equals to f of s minus a. Secondary shifting property or second shifting theorem or second translation, it is given by L of f of t is equals to f of s and g of t is equals to f of t minus a when t is greater than 0 and 0 when t is less than a. Then L of g of t is given as e power minus as into f of s. Laplace transformation for derivatives. If we want to use Laplace transform the derivatives, we have to do the division. We have to do the multiplication of the numbers, how many times it is given. L of f of t is equals to f of s, then L of f dash of t is equals to s into f of s minus f of 0. Laplace transformation of integral is given by L of f of t is equals to f of s, then L of integral 0 to t f of u du is f of s by s. How many times you have integral, you have to divide by the same thing of that many times. Multiplication by t power n. If f of t is equals to f of s and L of t power n of f of t is equals to minus 1 whole power n, f power of n into s. Division by t. Multiplication is done in the case of derivations and division is done in the case of integral properties. Division by t. If L of f of t is equal to f of s, then L of f of t by t is equal to integral 0 to infinity f of u du, provided limit of t is equal to 0 to f of t by t exist. So here are some basic functions of Laplace transforms. If L of 1 is given by 1 by s, L of t is given by 1 by s square, L of t power n is given by n factorial by s to the power of n plus 1, and sine kt is given by k by s square plus k square, and L of cos kt is given by s square plus k square. If cos square kt is there, it is given by s square plus 2k square by s into s square plus 4k square. E power 8, L of Laplace of e power 8 is given by 1 by s minus a, and t power n into e power 8 is given by n factorial by s minus a whole power of n plus 1, where n is a positive integer, it can't be negative. And sine square hkt and cos square hkt is given by as similar as L of cos, but just simply it will change in s square minus 4k square, and it is given by s square minus 2k square by s into s square minus 4k square. Both are similar, but in sin h square we use 2k, and cos h square k we use just s square minus 2k square. So what now the topic is inverse Laplace transform. Definition of inverse Laplace transform means uh, generally a Laplace transform is changing into an algebraic expression, and if you use inverse Laplace transform, changing this algebraic expression to again a Laplace transform. So changing of this is called as the Laplace transform technique method. So inverse Laplace transform, it is given by, it is in order to apply Laplace transform to physical problems, it is necessary to invoke the inverse transform L of f of t is equal to f of s. Then inverse Laplace transform is given by L inverse of f of s is equal to f of t. Exactly, in the Laplace transform we change the domain to the complex frequency domain. Now again we are changing the complex frequency domain to the same time domain by using inverse Laplace transform. So here are some few elementary properties. Linear property, same L inverse of C1 F1 of S plus C2 F2 of S is equal to C1 F1 of T plus C2 F2 of T. These are exactly the same, where we notice that L of C1 F of T and plus C2 F2 of T, just L comes this side, so it becomes L inverse. So this will be the same properties as Laplace transform only, but if you change the L from one side to another side, it will become L inverse. So like we using these formulas, we can easily calculate all, we can easily calculate the algebraic expressions to again the mathematical domains. The first and stating property is given by L inverse of f of s minus a is equals to L of e power at into f of t. And first shifting theorem is given by L inverse of f of t du is equals to f of t by t. Second shifting theorem is given by L inverse of f of s is equals to f of t. And again, here also we have inverse Laplace transform of derivative. L inverse of f of s equals to f of t. In that case, L inverse of f power n into s is equals to L L inverse of d power n by ds power n. How many times we have the power of n's? We have to do that many times derivation to the inner function, and then we will get an minus 1 whole power n, t power n into f of t. So next, multiplication by s. If L inverse of f of s is equals to f of t, f of 0 is given as following things. L inverse of s into f of s is equals to f inverse of t. So division by s. L inverse of f of s is equals to f of t, and it is also given as L inverse of f of s by s is equals to integral of 0 to t and f of u du. You're using the first shifting theorem here by where we are dividing an inverse Laplace transform of product of two functions. It is also called as convolution theorem. If L inverse of f of s is equal to f of t and L inverse of g of s is equal to g of t, then L inverse of f of s into g of s is equals to integral of 0 to t f of u du g into t minus u du, which is also known as convolution of f of t, f of g, of f and g. These are some basics of Laplace inverse Laplace transform of some basic functions. T power n is given by t power n by n factorial. 1 by s minus a is e power at. 1 by s square plus a square is given by e sine at by a. 1 by s square s minus a whole square is given by t into e power at. The same functions, just the values will be given on the left side, and L inverse will If we do the values of L inverse to the right side, we'll get again the left side values. If we do the L of left side values, we'll get the right side values. So this process is called as Laplace and inverse Laplace transforms. So application of Laplace transforms, solving ordinary differential equations. For example, y double dash plus a y dash plus by is equal to g of t. Subject to the initial conditions, y of 0, a comma y dash of 0 is equal to b, where and ab are constants. Solution: Laplace transforms of yt must be y of s, or more concisely y. Then solve y in terms of s. Take the inverse transform. We obtain a solution of y. This is some of the examples how to solve the inverse Laplace or Laplace derivations, and it is also used for solving electrical circuit problems. Some applications of Laplace transforms are to determine structure and astronomical objects from the spectrum, to find the momentum of a generating function in statistics, to determine the present value of console or bond in economics, to solve the problem related to communication and network analysis, to make a question in simple form, and equation like vibration of a spring, to solve mixing problem involving two tanks. A limitation of Laplace transform: only it can be used to solve differential equations with known constants. An equation without known constants, then this method is useless. And now here we conclude this topic. Laplace transform is a powerful tool using in different areas of mathematics, physics, and engineering. With the ease of application of Laplace transforms in many applications, many research software have made it possible to simulate Laplace transformal equations directly, which has a good made of advancement in the research field. So this is my topic for this time. Thank you.